Scientists developed tech to manage two-way power flow to commercial buildings. From the Ornell website, link in the description below, like and subscribe. Researchers at Oak Ridge National Laboratory recently demonstrated a new technology to better control how power flows to and from commercial buildings equipped with solar, wind, or other renewable energy generation. We are creating an electric grid of the future that allows renewable energy to be deployed in the most effective way, said Ornell's Madhu Chintavalli, who leads the research. With this new grid interface architecture, operators can control energy flows much more meaningfully, even when power generation is decentralized. Renewable energy is key to helping the U.S. electricity sector achieve national decarbonization goals. But they also add uncertainty to the electrical grid because they are unevenly available across the country and generate electricity intermittently. Developing and coordinating power electronic systems to incorporate these resources more easily is vital to creating a more resilient grid for reliable electricity. Chintavalli's research team designed a hybrid AC-DC power electronics hub to act as a gatekeeper between the larger grid and the subsystems including renewables, generators, and battery storage. The technology was developed and tested in the Department of Energy's Grid Research Integration and Deployment System, or GridC, at Ornell. GridC offers a unique platform for building power electronic systems, starting with the smallest component, then testing and demonstrating full systems that incorporate both hardware and simulation. In the Low Voltage Lab, rows of metal containers house Ornell-developed power electronic converters, trailing cords thicker than a wrist and ending in plugs as wide as a plate. These converters provide different levels of power to electrical feeds based on different scenarios. They are paired with equally large power emulators that can mimic energy delivered by a solar array or battery system. Huge touchscreens allow engineers to rearrange the system and tweak its operation. Ornell engineers designed the power electronics hub to control how the converters interact with each other and the grid. Emulators are set up to mimic the electrical draw and generation of a solar array. A storage battery, an emergency generator, and a critical data center with high electrical demand. The Power Electronics Hub was programmed to autonomously manage the power flow of all these electrical loads, helping prevent fluctuations in supply and demand on the wider electrical grid. The Power Electronics Hub plays the role of a middle manager between the larger electric grid and the local power electronics. Instead of the utility talking to, say, 1 million resources, this technology reduces that number by a factor of 10, said Ornell's Michael Stark, lead software architect for the project. From a utility's point of view, all the equipment managed by the Power Electronics Hub functions as a single system. This is an advantage for power companies faced with incorporating distributed and intermittent energy from solar, wind, geothermal, and other renewable sources into a century-old grid that was designed to push steady flows of energy out from centralized power plants. Similar concepts have been tested by some utilities, but these approaches use a single vendor's proprietary products in a prescribed way. Stark said, because Ornell constructed the power electronic converters and many of the components, the resulting technology is openly available and can be customized to achieve specific goals. For example, experiments by Chintavalli's team have shown the Power Electronics Hub can prioritize providing the most cost savings to customer-owned systems or providing a consistent supply of power for utility systems. Ornell researchers demonstrated that these objectives can be integrated directly into the hardware and software, and they have also developed the supporting communication and control infrastructure. It starts with pre-testing and pre-automating systems that can be easily scaled up and deployed quickly, said Chintavalli, adding that the project has led to 3 patent applications. We're trying to standardize systems so they are interoperable. Moving beyond modeling to demonstrating the technology in wired hardware was a milestone that was only possible because of Ornell's capabilities in GridC. This is the only place where we could develop both the software and hardware to fully prepare to deploy this technology to industry, Chintavalli said. Several industries could see significant benefits. The technology could be used by a builder or building owner to save money and energy, or it could be installed by a utility for enhanced power control and reliability. The team is moving to the next step in the research, substituting higher power commercial converters secured directly from industry. This will demonstrate the Power Electronics Hub can manage the megawatts of power handled by electric utilities using components from commercial suppliers. The Ornell team that developed the Power Electronics Hub includes Stephen Campbell, lead architect for systems integration, Ben Dean, communications interface developer, Jonathan Harder, hardware systems specialist, and Rafal Wajda, magnetic systems specialist. We are now working on how to extend these power electronics hubs from small scale to thousands working together, coordinating to deliver energy as needed from all sorts of different angles and different sources, Stark said. We're trying to show that the Power Electronics Hub can act like a battery almost, pushing power in and out under our control. That provides all kinds of flexibility to the grid that wasn't there before. The Power Electronics Hub is an example of the type of technology developed in Grid C that could be deployed with a potential consortium of partners. Ornell held an interest meeting today with stakeholders from industry, utilities and research institutions to discuss power electronics challenges and strategies. Participants discussed a possible framework for an organization to accelerate development and deployment of power electronic systems for managing the electric grid of the future. UT Patil manages Ornell for the Department of Energy's Office of Science, the single largest supporter of basic research in the physical sciences in the United States. The Office of Science is working to address some of the most pressing challenges of our time. For more information, please visit energy.gov/science.